Hello everyone. Myself Manish Kumar. I am from Computer Science Engineering Data Science. Section Devo. Subject Mathematics. Topic Conduction of Heat. Let us discuss about conduction of heat. Introduction to heat conduction. Heat conduction is the process through which the thermal energy is transferred within a material. It occurs when there is a temperature difference within the material or between materials. This transfer can happen in solids, liquids, and gases through the its most effective efficient in solids. Basic principles of heat transfer. Heat transfer happens through microscopic uh, collision between particles. The energy move from region of higher temperature to region of lower temperature. This process continues until thermal equilibrium is reached between the materials. Fourier's law of heat conduction. Fourier's law quantities the rate of heat transfer through a material. It states that the heat transfer rate is proportional to negative gradient of temperature. The equation is expressed as Q equals to minus Ka dt by dx, where Q is heat transfer, K is thermal conductivity, A is area, and dt by dx is the temperature gradient. Thermal conductivity. Thermal conductivity is a material property that indicates how well a material conducts heat. It denoted by a symbol K and varies widely among the differences materials. Metals generally have higher thermal conductivity while inserting materials having lower thermal conductivities. Factors affecting heat conduction. Several factors influencing the rate of heat conduction, including the temperature differences and material properties. Surface area and thickness of the material also play a significant role in heat transfer. The type of material and its phase, solid, liquid, or gas, can greatly affect conduction efficiency. Conduction in solids. In solids, conduction occurs primarily through lattice vibration and a free electron movement. Metals which have free electron conduct heat much more efficient than non-metals. The arrangement of an atoms and their bonding types can significantly impair their conductivity. Conduction in liquids. Liquid conduction heat through both molecular collision and convection currents. While liquids have lower thermal conductivity compared to solids, they can still transfer heat efficiently. The movement of molecules in liquid allows for a different mechanisms of heat transfer compared to solids. Conduction in gases. Gases generally have the lowest thermal conductivity among the three phases of matter. Heat conduction in gases occurs primarily through molecules collisions, which are less frequent than liquids and solids. The low density of a gas molecule results in slower heat transfer rates. Applications of heat conduction. Understanding heat conduction is essential in various energies applications such as thermal insulations. It is also crucial in designing heat exchangers and electronic devices to manage heat. In cooking condition, heat primary method of heating transfer in pots and pans. Real world examples. A common examples of a conduction is a metal spoons heating up when placed in a hot liquid. Insulation in building is designed to minimize heat conduction, keeping interior warm or cool. Heat skins in electronics are used to disperse heat away from sensitive components to conduction. Measurement of thermal conductivity. Thermal conductivity can be measured using various methods, including guided hot plate and laser flash. These techniques assess how quickly heat passes through a metals under controlled condition. Accurate measurements is crucial for selecting material in engineering and constructions. Heat conduction in everyday life. We experience heat conduction daily, such as when touching a hot stove. Cooking methods like baking and frying rely on conduction to transfer heat to food. The design of heat retaining metals in clothing is based on principles of heat conduction. Conduction versus other heat transfer methods. Conduction differs from convection, which involves the movement of fluids and radiations, which transfer energy through electromagnetic waves. Each method has its two own mechanisms. and efficiency depends on environment. In many systems, all three methods of heat transfer can occur simultaneously. Challenges in heat conduction. Efficiency heat conduction can be challenged in materials that are meant to insulate. Engineers must balance thermal conductivity with the durability and cost in materials selections. In high performance applications, managing heat conduction is essential to prevent overheating. Conclusion and further directions. Understanding heat conduction is a vital for advancements in technology and energy efficiency. Further research may focus on developing material with tailored thermal properties for specific applications. Innovations in heat conduction can lead to improvement in energy conservation and thermal management solution. This presentation provides a comparison overview of heat conduction covering its